Hey everyone, welcome back. In this video, I'll walk you through a complete Python script that fine-tunes Stable Diffusion Turbo using LoRa adapters. I'll explain each step in simple terms and show you the exact code you can run. Let's dive in. Step 1. Imports. First, we import all the libraries we need: PyTorch for training, diffusers for Stable Diffusion, transformers for text encoding, PEFT for LoRa, and a few helpers. Step 2, basic config. Now we set 3 key paths: the base model we'll fine-tune, a JSON dataset file, and where to save our LoRa checkpoint. Step 3, load model and tokenizer. We load the SD Turbo pipeline, clip tokenizer, and text encoder in float16 for speed and VRAM savings, then move them to the GPU. Step 4, configure LoRa. LoRa lets us fine-tune only small, targeted parts of the UNet. That's faster and lighter. We attach LoRa to attention-related modules and confirm trainable params. Step 5, dataset class plus data loader. Our dataset is a JSON list of prompt equals and image equals path.jpg. We resize images to 736 by 736 and return prompt plus tensor. Step 6, optimizer, scheduler, accelerator. We'll use AtomW with a small learning rate and a constant scheduler. Accelerator wraps everything for efficient mixed precision training. Step 7, resume if checkpoint exists. If you've trained before, we resume, otherwise we start fresh. Step 8, training loop. Here's the core training logic. Tokenize prompts, get text embeddings, encode images to latents, sample a time step and add noise, predict noise with the UNet, compute MSE loss and backprop, optimizer step, and scheduler step. Step 9, save LoRa plus state. When training finishes, we save both the accelerator state and the LoRa weights. This includes the adapter config.json needed for loading later. And that's the full fine-tuning pipeline with LoRa on Stable Diffusion Turbo. If this helped, drop a like, subscribe for more hands-on AI videos, and comment what you want next. Maybe the inference script using this LoRa? See you in the next one. Wave.